Hi, everyone. Welcome to the Vector Kickoff event. We are so excited that you're here. Just to go over our agenda for this afternoon. So we're going to have some opening remarks. If you're a company just joining, if you're a cohort company participating in this iteration of Vector, please add your company name in front of your actual name so that it'll make it easier for us to facilitate the breakout rooms in a bit. So we'll just have some opening remarks, move into just some rapid fire intros from our cohort companies. We'll do a quick round of mentor introductions for those on the call, and then we'll finish up with some breakout rooms for our teams and mentors to get to know each other a little bit better, talk about different aspects of the industry and space. And then we're going to finish it off with a quick overview of our the curriculum platform that we'll be using before we wrap everything up for the day. So without further ado, we're going to go ahead and get started. If some of y'all could monitor the breakout, or not the breakout, the waiting room, that would be fantastic. Okay. Hi, everyone. If you hadn't guessed, I'm Caroline. I am the NSIN Vector Program Manager. A little bit more about me. So I've worn several different hats during my 4 years here at NSIN. I started off as an intern in the Chief of Staff's office back in 2020, where I really just fell in love with the mission and the incredible people that I get to work with every day. I moved into a full-time role here in our data cell and worked as an analyst for a little over a year before transitioning into the program management in our venture portfolio back in August of 2022. So this is my second cohort with the Vector program, and I have to say that it holds a very special place in my heart. NSIN is the organization that gave me my start in government. They opened the door for me and gave me an opportunity to start my career in public service. And that is the central mission of the Vector program, to demystify the government space and help you and your teams break into business with the Department of Defense. All that to say, this is a bit of a full circle program for me, and I am so very grateful to share it with all of you. So for those of you who might not know, and might be wondering, what is NSIN? The National Security Innovation Network is a Department of Defense program office aligned with the Defense Innovation Unit, reporting directly to the Secretary of Defense, just to give you an idea of where we sit. We were created in 2016 with one mission, which is to change the way the Department of Defense solves problems. We do so by delivering high quality, targeted programming to mature and expand the national security innovation base, and by placing highly qualified experts across the U.S. in areas of known and unknown interest to the department. So we are located in places you might expect, like Austin, San Francisco, but more importantly, in places you might not, like Kansas and South Dakota. And that is very intentional. We know that there are amazingly talented people and technology resident across the U.S. With capabilities of interest to us. We are an organization made up of about 100 people and growing every day with 3 distinct teams, our regional network team, our enterprise service team, and our program team. So our regional network team is composed of regional engagement principals or reps spread out across our 9 NSIN regions who engage with local venture and academic communities. Some of your local reps are in the audience today, and I know they're very excited to work with you. Our enterprise services team is made up of our data cell and our transition cell. The NSIN transition cell is a team you'll get to know well throughout the cohort. They're a team of subject matter experts with deep knowledge of the government contracting and private capital spaces, and they provide post-program support and services to our NSIN alumni teams to help them navigate the defense space and set them up for success post-program. And last but not least is our NSIN program team. So we have 2 portfolios, the venture portfolio and the talent portfolio. The talent portfolio works to identify non-traditional problem solvers and solutions from academia. And the venture team works to connect early stage companies to the DoD. If you hadn't guessed, Vector is aligned with NSIN's venture portfolio. Which brings me to the reason we're all here, which is Vector and all of you. So for those in the audience who might not know, Vector is a 10-week accelerator program that we put on with our awesome partners here at Decisive Point. Throughout the program, our 20 teams will get a comprehensive crash course in how to do business with the government. You'll learn the landscape and be equipped with the tools and knowledge to be successful after the program. The Vector program culminates in a final pitch competition where the top 3 teams will receive prize awards from our $50K prize pot. So you might be wondering, like, who is the cohort? As I mentioned earlier, one of NSIN's missions is to change the way the Department of Defense innovates. And we believe that that starts here with all of you. So the 2024 Vector cohort is, in my very humble opinion, the most impressive we have ever had. So we received nearly 200 applications this year for only 20 cohort spots, making this the most competitive selection process in cohort to date. And your teams are here because we found your technologies to be compelling, novel, and exciting. This cohort is record-breaking not only in terms of applications, but also in the strength and diversity of our participants. So to give you an idea of who you'll be learning with and alongside, 40% of our cohort is women-owned, and 25% of our companies are also minority-owned, which I think is just absolutely fantastic, both of which are records for the Vector program. Additionally, your peers come from 11 different states spanning 4 time zones, and you all represent the best and brightest of your respective ecosystems. We also have 3 NSIN alumni teams in this cohort, 1 former student team from our Hacking for Defense program, a recent alum of our Emerge Accelerator, as well as a finalist from our Challenges Prize competition program. So welcome back to our alumni team. That being said, I do want to emphasize that while our teams come from a range of different backgrounds and experiences, all of you are fairly new to the defense space, and it is clear you have so much to offer. I am so excited to get to know all of you throughout the course of the accelerator. I think I speak for myself and the rest of the NSIN team when I say that we are so eager to help you take the next step in your innovation journey. So now I will stop talking and I will turn it over to Ryan to introduce herself and the Decisive Point team, but congratulations to all of our cohort members.
Hey everyone, thanks Caroline. Big congrats. So excited. This program is going to be great. We rounded up some awesome mentors. Wonderful to see the familiar shining faces here and some new faces. If you're not familiar about Decisive Point, we are a venture capital firm based in Washington, D.C., New York, and Boston. We're an amazing team of former military service members, acquisition professionals, and entrepreneurs as well. We've been working with NSIN since 2021, working very closely with our government partners. We are here to help you figure out if government and doing business with the DoD is right for you. And if you have some initial traction, we're going to help you build upon that. And if you're brand new to the space, we are going to teach you everything you ever wanted to know about the DoD and working with the government. I'm joined by some great people on my team, and I'm going to let them introduce themselves. So we'll start with Laura. Many of you have probably seen a lot of emails from her. Laura, could you just say hello?
Hi, I'm Laura. I sit in the New York office here with Jackie. I do a lot of the operations side for Vector and the NSIN program. So I look forward to working very closely with all of you. Great.
And Jacqueline?
Yep, Jacqueline, also sit in the New York office, and looking forward to working with everyone as well. And we also have Julia.
Oh, Julia, sorry.
Hi, all good, just setting up, but nice to meet you all. Also Decisive Point, also in the New York office, sitting right behind Jacqueline and Laura.
great. So these three wonderful women all bring a great experience from finance, venture, international and global affairs, as well as U.S. Navy. So with that, I will kick it back over to the Vector team, but wanted to say welcome.
Okay, so now we're going to go through our rapid fire presentations with our cohort teams. So each company has prepared a quad chart that they're going to present. They're going to have 2 minutes to present their quad chart. So we'll kick things off first with aerobotics.
Hi, everyone. So thanks a lot for having us on this cohort. We're very excited to working together on our mission. I'm Harsh Zala. I'm the CEO and co-founder at Aerobotics 7. We're building an autonomy platform to detect, identify, and deny hidden threats such as landmines, IEDs, unexploded ordnances, and any asymmetric and emerging threats and obstacles that emerge in next-gen breaching requirements in all three domains, air, land, and sea. We're building a UAV-based system as of right now, but our platform can be integrated to existing vehicles in either a UAV, UGV, or an underwater underwater vehicle as well. We're building an autonomy software to have the multi-agent communication and real-time insights. Our goal is to empower the warfighters at the front edge of the battlefield by giving them unique insights of these hidden threats and obstacles, target recognitions and pattern recognition, but allow them the ability to respond to such threats in real time as well. So far, we've secured a strong letter of intent from the Ukraine Ministry of Defense to deploy our platforms. We're engaged with the Army Futures Command, JPO, and C5ISR for their next-gen breaching requirement we're closely working with. We have surpassed TRL6. We validated our system with relevant environment. So far achieved 95% plus accuracy in detecting buried non-metallic targets. And some of the advantages I just mentioned. We're still working on a business model, but initially the platform would cost starting from 175K per system. On top of that, we charge for the software AI model and extensive threats library starting 120,000 a year. Looking forward to working with everyone. Thank you.
Great, thank you so much. Next up, we have Andrina.
We just changed the logo to have the M in there, so
Okay.
but no worries. Hello, everyone. We're super excited to be a part of the cohort as well. My name is Matt Cernisek. I'm the CEO and co-founder of Adrenum. Next to me is Alex. He's the CTO and co-founder, so I'll quickly step through what we're doing. Adrenum is seeking to build a distributed mesh network, kind of analogous to a spider web in terms of subsea sensing. And the overall goal of this would be to define and give greater level of perception for autonomous maritime vehicles, such as UUVs and USVs, to help better track and locate drones of interest or nefarious traits and engage them and neutralize them. So currently we are at a test readiness level of about 3. We have a subscale model that we have tested and verified at home. Pretty much the point of this and the advantage of what we're trying to do here is to move away from low lasting sonobuoys type A, such sonobuoys for anti-submarine warfare tracking, and also for the drone systems that I mentioned. Kind of moving forward into the commercial side of things, this further has applications for monitoring of various ports and interest areas such as choke points, oil and gas monitoring for offshore rigs in case there are spills, and then also commercial fishing, which we're starting to heavily lean towards as well. In terms of our traction from the commercial side, we have none at the moment. In terms of the Department of Defense, we have a contract, a phase 1 contract with OSD for the development of this. And actually, as of this morning, we have secured JPEM testing at the end of August for the V2 prototype that we are discussing or that we're building. So that would be to track those unmanned maritime vehicles in situ in a real environment in Maryland. So we're super pumped about that. In terms of our business model, our prototype costs are about $5,000 a unit. We haven't really kind of gotten into the nitty-gritty and into how much we would be charging for each unit. So we'll pretty much just leave it at that. And then we just have a little roadmap for our development process and how we anticipate that looking. So yeah, thank you so much. Again, appreciate the opportunity and looking forward to meeting everyone.
Great, thanks so much. Next up, we have Anuma Aerospace.
Hi, I'm Diana Little, CEO of Anuma Aerospace. Jamie Little, the CTO, is also on the phone. What our long-term goal is to decarbonize long-haul heavy lift transportation with a new form of lift for airships. But on our way there, which is a pretty long-term goal, we have a weather sensor platform that we are currently working on with NOAA. And the next stage up is a 2-cell intelligence, surveillance, and reconnaissance platform for pretty much any kind of sensing, command and control, data sharing, drone mothership. It could be used for a lot of things. We have a patent on the PBL cell technology. We have a pending patent on another piece of technology, which will help even decarbonize even further what we're doing. This would be completely autonomous, can stay persistent at a timescale of years rather than months. And it's expensive, it's made of carbon fiber, but this is completely eliminates the need for helium or hydrogen in lighter than air vehicles. And lighter than air vehicles are really excellent for this kind of persistent ISR solution. The operational cost should be incredibly low. Again, it's drone piloted. It is should stay resident for a very, very long period of time. TRL is currently 4, MRL is about the same. We are raising money right now to raise those up to 6. And we will be starting a NOAA phase 2 in September for the weather platform, which helps us de-risk this and get us to the next step.
Great, thank you so much. Next up, we have Better Zinc batteries.
Hi, everyone. Nice to meet you all. I'm Vivian. I'm one of the co-founders. And so we're a group that developed this technology as researchers out of Berkeley National Lab. And so our team is based in the Bay Area. And we currently have a lab scale prototype, so TRL4, and are currently running experiments just to prove the longevity of our systems. And what we're focused on is really being able to create a longer lasting, safer alternative for long duration energy storage. And our battery system in particular has some advantages in terms of flexibility with scaling, as well as increased temperatures for operability. So we're exploring different markets right now, still working on our business model, but just the underlying chemistry just allows us to explore a lot of different use cases on both the government and commercial side. So yeah, thanks again, and excited to learn from you all.
Great, thanks so much, Vivian. Next up, we have Dayton Photonics.
Hi, I'm Emily Furman Corey, and I'm the CEO of Dayton Photonics, and I'm the co-founder of Dayton Photonics with my partner, Cullen Bradley. Our technology is a free space optical communication system, and we're using it to bring communication to the most challenging places on Earth. Our primary use cases are for electromagnetically denied environments for the DoD, and we are also used for platforms in motion. We currently have traction as well with broadband internet infrastructure. So that's our commercial use case. We are in serious talks with some mid-tier ISPs to do pilot demonstrations of our technology this summer. And we have significant interest from AFRL as well. We had a SBIR phase 1 and 2 that developed this technology with the Air Force Research Lab Information Directorate. And we also demonstrated the technology at the Naval Info War Center, at their 3-path Monty. We've also done customer discovery with FEMA and the National Guard, looking at pop-up deployable networks, specifically for national disaster, natural disaster, and terrorist situations where they need to immediately restore communications. We're also a client company of the Entrepreneur Center in Dayton, Ohio, where we're funded by the Ohio Third Frontier, and we're in our angel round of investment. Thank you.
Thanks so much. Next up, we have Diffract Tech.
Hi, everyone. I'm George Herring, founder and CEO of Diffract Technology. What we're doing is we're taking volumetric 3-dimensional holographic projections, and these are large field of view holographic projections, and applying them to 3D sensing, integrated motion control, and real-time display. Currently, we're at a TRL level around 3 or 4. We've proved out most of these things on a benchtop prototypes, and we're applying it to advanced sensing. And the advantage of this is that by using a holographic projection system, we can both do 3-dimensional sensing and control in a single integrated package. So there isn't any there isn't any miscommunication between systems or problems with alignment or recalibration. Because it's all integrated into one system, it means that we can basically use a little receiver on a robot and then tell the robot where to go and also what its surrounding environment is. So we're currently applying this primarily to commercial applications with closed loop manufacturing and automated control. We're looking into whether there's a good fit for a government customer. We've had a phase 1 SBIR from AFWorks and a NSF SBIR phase 1. Our business model, it takes about $2,000 for our cost of goods sold, around $10K for our sale price that we're targeting, with a software as a service recurring revenue market plan. And then we're looking at applying this on the civilian market side to Industry 4.0, automation in the manufacturing construction space. And we're trying to see, how that would fit with the defense space.
Great, thank you so much. Next up, we have KMB.
Hey, I'm Brian. I'm here with Marco. We're co-founders of KMB Telematics. We're based here in Washington, D.C., and we make radar. We started out 4 years ago trying to make the best radar to detect drones. We do 4 things which are unique. One of our advisors is a guy who's paid to fly drones legally into the White House and other sensitive defense facilities to penetration test them. So we asked him, hey, how could we make your life as miserable as possible as an attacker? And he told us to do the following. 1, that we need to see stationary hovering drones. So that's something that we do. Second, this is the first radar that can be used on a moving vehicle for kind of the same reason. If you can see stuff that's stationary, you can also see stuff that's moving at your speed when you're moving. Third, we can see a full swarm of drones because this is not a phased array. What we're actually doing is building an RF image, a volumetric 3D point cloud, if you will. And so we can see basically any targets in the scene that are reflecting. And then finally, because of that, we can use this radar in a relatively crowded or cluttered environment like a city. We think that, of course, drone proliferation is a big problem right now, and we have the technology. We're nerds with laptops. We want to figure out how to commercialize it. That's why we're here, and we're really excited to learn from all of you. So far, we've had a little bit of traction. We had a SBIR phase 1, 2, and 2E from NASA. NASA funded this as sort of originally as a detect and avoid sensor, and then we sort of pivoted it toward being like an airspace, air traffic control type sensor. We've also been a subcontractor on a couple of minor DoD contracts for trade studies. So not really what we want to be doing, which is delivering hardware, but we've done a trade study for the Army, and we did a trade study for radar for DARPA. That's actually ongoing right now. So yeah, looking forward to participation in the program, and just really kind of humbled by how legit all of your companies are. So excited to be a part of this.
Great, thank you so much. Next up, we have Levanta Tech.
Good afternoon. Great to be with everyone. So Kelly Eccles, CEO and founder of Levanta Tech. I'll apologize in advance if a truck goes by. I'm in the my workshop. I'm based out of Missouri, but we're doing our prototype testing in Gulfport, Mississippi, and I'm at the port of Gulfport working on the prototype as we speak. We are developing a sea-launched aerial drone. This is a first of its kind drone. We fill a gap in current technology. Quadcopter drones, even helicopters cannot land on the ocean and float for extended periods of time due to rough seas. The center of gravity of the vehicles is such that it'll cause them to capsize in the rough waves. Likewise, seaplanes cannot land on the ocean and handle rough seas. So our drone's designed to float on the ocean, essentially ride waves like a surfboard, and be able to take off in rough sea conditions. Our wings are submerged while we're floating. And so in terms of just some of the capabilities that this enables for us is that, one, we can be deployed from vessels or from shore, but we can float indefinitely with our motors primarily off, preserving power. And then we also float with low detectability. We sit essentially like a low turtle in the water. There's not a lot visible in the water. Gives us the ability to do an asymmetric pop-up, where we can pop up, enable long range line of sight communications, enable SATCOM. There's a number of things we can do with a brief pop up, but we're also capable of sustained flight. So a number of different applications with the drone we're building right now is the Group 2 UAS. So that means it's roughly around 55 pounds. We've also got Group 3 and Group 4 drones envisioned. The business model for us is really to develop a low-cost, attritable drone that's mass-producible, where we can produce, say, hundreds of these per month, preferably at the point of need. The war in Ukraine, it demonstrates one use case for our drone. You have the Ukrainian Navy. Ukraine is defeating the Russian Navy without a navy, and every navy in the world is trying to figure out how to protect their fleet. Having a fleet of low-cost drones floating in the perimeter of the fleet operations, and the ability to pop up, and we can track anything under the water, on the water, faster than it can move, and also be used to engage with aerial assets. So there's a number of different applications on ISR and fleet defense, but that's Levanta Tech in a nutshell.
Great, thank you so much. Next up, we have NeuroSmart.
Oops. Hi, my name is Arosa Azimi. I'm a research assistant with NeuroSmart. Dr. Melise Sielmes-Balban won't be here with us today, but I'll be representing us. So we are developing a biofeedback tool to cultivate mental resilience in special operators. So at the moment, we have the way this technology works is we mount officers with video to live stream the data to their trainers, who are viewing the stress metrics at the same time as the video data. So from that, they're able to visualize the ability for officers to regulate their stress. So what we've done, we've identified significant markers of stress, and with that, we can understand the stress management skills of officers and the efficacy of current training. So our use cases, it's been used as an objective tool to measure operator stress management skills. So as an assessment tool to identify how effective the current training is. And it's been used as a special operator training for stress resilience. So currently we're gaining traction with law enforcement, with Abbotsford PD in Canada. They've purchased our solution, and the City of Miami Police Department and Newcastle Police Department are currently going through procurement. Several other law enforcement academies are also piloting for recruit training. So we are gaining some traction there. Summary of our technology. So we are at a number 6 for TRL. our TRL. And so we've tested in law enforcement training academies, SWAT training, and in-service scenario training. But yeah. Our market, we are looking to expand to command and control as well to identify other industries that require a certain amount of cognitive control. Let me see. And our advantages are that we offer an objective measure of stress management capacity for individuals and teams, enabling goal setting and selection. And we also offer immediate live feedback to the users with interventions to improve if they're not self-regulating. So their trainer that's looking at the video data and the stress data are able to, by visualizing the ability of their ability to regulate stress, they can also send out the live alerts to begin interventions. Our business model is that we charge $2,500 a seat for upfront costs, including a first-year subscription, and $1,500 per seat for yearly hardware software subscription. But yeah.
Great. Thank you so much. Of course. Next up, we have OSO Semiconductor.
Hi, everyone. Yes, very excited to be here. Very excited to meet all of you. Also, Semiconductor is making ultra-low power RF beamforming chipsets for phased array antennas. So these are the antennas that we use for radar systems, SATCOM systems, 5G systems. Basically, most of the modern communication sensing that's done wirelessly depends in some ways on phased array technology. We have a new IP that we developed out of UC Berkeley that dramatically improves the efficiency of the core blocks inside these chipsets, allowing us to deliver up to 4x or more reductions in power consumptions, significant reductions in silicon size and overall system cost, and then improvements in linearity. So again, the use cases are SATCOM and radar. You can think, a lot of the cohort companies are presenting on drones. And as you can imagine, these drones and smaller mobile platforms are generally very power constrained. And so having a more power efficient payload, whether that's the sensor or comms platform, is very beneficial. We have a TRL level of 4. We taped out our initial technology chipsets in 2022, and our new IP has only built upon that. The advantages include, as I mentioned, having lower power consumption, so smaller SWaP-C, or higher performance for a given SWaP-C. We can also reduce the number of expensive 3.5 devices, and we can enable new capabilities by putting these communication phased arrays on platforms that previously they were inaccessible to. In terms of our business model, we are a fabless semiconductor company. We also do some antenna OEM design, but generally we produce the chips, in some cases the antennas, and then we work with other OEMs or system integrators to eventually send to end users, which would include, of course, the DoD. And I actually don't think I introduced myself, but I'm Matthew Anderson. I'm the founder and CEO, and yeah, very excited to work with you all.
Great, thank you so much. Next up, we have Precision Terra.
Hi, I'm Maitre. I am the founder and CEO of Precision Terra. We are improving the ability to track GPS signal in what I define as challenging navigation environments. So that includes places like cities, forests, mountain areas, places where you might imagine there are a lot of signal obstructions that can interfere with GPS signal as it's traveling from a satellite in space down to a GPS receiver on Earth. And those interferences can weaken GPS signal ultimately so considerably that it can be really challenging to actually lock to that signal and track it consistently through those environments. So this is a solution spun out of technology developed at the University of Colorado Boulder into a full-fledged company. And then beyond the core kind of tracking algorithm, we're building an end-to-end GNSS or GPS signal processing unit that allows us to take the raw GNSS signal all the way through the tracking process and to actually get positioning coordinates out. So this is a software-based solution. I believe that the TRL is approximately around 3 or 4 range, but would be interested in NSIN's perspective in how that translates the TRL kind of assessment to a fully software-based solution. In terms of the advantages that this technology provides, it can be implemented in a fully software-defined manner. So there are a lot of different ways to enhance signal tracking in a GPS receiver, but this being software defined can make it a more cost-effective solution. And it's also a generalized approach that addresses a lot of different forms of signal degradation. So buildings, trees, and these terrestrial objects are one way that signal can be degraded, but inclement weather in the Earth's troposphere, and then effects like northern lights in the Earth's ionosphere can also affect signal and weaken it considerably. So this is a generalized algorithm that addresses all of those different interferences. And then it also dynamically switches between traditional tracking methods and this kind of novel tracking method that looks at multiple GPS frequencies in parallel with one another to derive a better tracking solution. So because of this dynamic nature, it's effective in a really broad range of environments compared to what you might normally see with the tracking algorithm. In terms of use cases from a commercial standpoint, vehicle navigation systems are really the area that we're focusing in addition to mobile device manufacturers that have built GPS chips. And then in terms of DoD applications, we're looking at unmanned aerial system navigation, as well as any on-the-ground GPS receivers operating in battlefield environments. While we don't have traditional government traction in terms of grants or any contracts or engagements with the DoD, we do have a letter of support from Raytheon, interest in following our progress as we develop our technology further. And then from a commercial standpoint, have a partnership with the GNSS software-defined receiver company and are under final engineering diligence with 2 large GNSS manufacturers. And then in terms of the business model, I have gotten a number of different perspectives on the direction we can go, but IP licensing is one kind of avenue we're considering, and additionally, like providing a full kind of package and licensing that entire software package to companies that would use our technology is another avenue that we're exploring. So that's a summary for Precision Terra. Thank you. I'm excited to be part of this cohort.
Great, thanks so much. Next up, we have Solid Intel.
Hi, my name is Meg Reese, and I'm the founder and CEO of Solid Intel. Really excited to be part of this cohort. So we are the first generative AI supply chain illumination company where we're heavily focused on supply chain risks that are heavily embedded in DoD contracting. So this is everything from 1260H companies. You have to keep Chinese military companies out of your supply chain if you want to sell into DoD. Things like sanctioned entities, et cetera. We are currently a TRL level 5, and the advantages of using Gen AI is we're able to develop very rapidly, as well as new algorithms that seek out new risk factors that DoD, the IC, other government entities care a lot about, but may not be embedded into contracts from the very early stages. We do use base data sets, but we also can build out algorithms to seek out specific types of risk information. So the customer or client is able to input some of their data, and then we can build out on top of that. We also give sourcing and citation information that DoD specifically requested, and we have a lot of room for experimentation. Our use cases on the commercial side are heavily focused on very, very stringent new laws and regulations that came into place over the last 2 or 3 years. Most specifically, the Uyghur Forced Labor Prevention Act that prevents any goods from being able to come into the country if they originate in one region in China. And then all of these additional layers of regulation for selling into the USG or the USG itself. Our earliest paying customers are in this Uyghur forced labor space, and on the government side, we actually have a decent amount of traction and conversations going on with DoD and the IC. We are being used at the moment by staff on the China Select Committee. We're in conversations with Tinker Air Force Base Supply Chain Wing. We're talking to both DIU and OSC at the moment. We're talking through experimentation with Keyport Underseas Warfare Experimentation Branch. Again, in talks with different folks at the IC. We're a subcontractor on the GSA scripts program. We are a subcontractor on a direct-to-phase 2 SBIR that the key entity hasn't managed to place in the Air Force yet. So if you guys have any suggestions or connections, we definitely appreciate those. And some of the really key points that the US government is talking to us about that our system is able to work on is working in the supply chain space on EVs, critical minerals, forced labor, sanctions entities, and also a significant key component is foreign ownership control and influence structuring. So our business model is we have a twofold depending on the size of the customer as well as the use cases. So we have both a per seat subscription. We have different sizes of the subscription based on the size of the company. And then we also have a token model when the customer doesn't have a clear idea of how many people are going to be using it, also to limit the problems of password sharing. And yeah, those are some of the major things right now. Thank you guys. Looking forward to this.
Thanks so much. Next up, we have StarCube.
Hey, good afternoon, everyone. I'm Chris Frick, CEO and founder of StarCube. We're a small modular reactor company building microreactors for critical infrastructure and crisis response. I want to start off with first a framing. You know, microreactors, they already exist today. There's kind of 31 microreactors on university campuses. For example, MIT has one, 6 megawatts, can power 6,000 houses. It's not connected to the grid. From 1949 to 1975, the U.S. kind of designed, built, and operated 52 different reactors in less than 4 years. So we've been kind of laser focused a little bit more on the business development and ecosystem side. In terms of establishing a path in order to bring microreactors and kind of a distributed fleet of nuclear microreactors to ensure energy independence and kind of energy kind of resilience. So some initial traction, we've established a strategic partnership with Worcester Polytechnic Institute. They had a research reactor for over 52 years, and there's a unique licensing aspect there. And also, we've got some very good feedback within the state of New Hampshire. A couple towns that are within an existing nuclear emergency planning zone. National Guard engaging 2 states, kind of adjutant generals who are interested in kind of demonstrations. And the last would being kind of Poland and Ukraine. Had an opportunity this past April to attend the Kyiv Economic Security Forum and kind of have discussions with the Ukrainian Minister of Energy. Right, and so yeah, we're focused on leveraging partly my background in the Navy as a nuclear submariner and bringing microreactors to bear to the broader commercial market. So thank you.
Great, thanks so much. Next up, we have Terawatts.
Hi, I'm Caitlin Suarez, the CEO, co-founder of Terawatts. We're working on a form of subsurface wireless power and data transfer. So we actually send a transmitter down a borehole, and then we can take any power generation, like nuclear, and transmit it through the rock and soil. It forms a radius in its current form, so you can create this like omnidirectional like field in the ground, and then anywhere in that field you can pick up the power with a receiver. And what's pretty cool is that it can work without, it's not like converting from like microwave or lasers back to electricity. It's like an electricity to electricity system. We can also operate devices without needing batteries. Some of the interesting near-term things. So we are tier level 4. It's spinning out of a university. We can do subsurface power, data transmission, but we can also use the currents themselves to make images. So we're exploring ways of like continuous power data to devices, and then also making an image from that. In the long term, I have like grand visions of this being another form of power transmission, like comparable to a wire. And so can we do things like electrify military bases? We are currently supported by an Activate Fellowship, and that's primarily the traction that we have in terms of grants. Activate helps train scientists from being a scientist into being an entrepreneur, and there's some funding for the company with that.
Yeah, the business model is still a little bit to be seen. I imagine doing like a turnkey system, so having the whole system and the operation of the software as one big package. It's top of mind, so I'll like point out that we use a form of conduction currents to send the power. So there actually are some subsea applications and potentially even sea ice, like salty ice. And so I've been talking with the Navy about potential grant funding with that. And I will have a conversation with Raytheon also on Friday. So I'm heading towards also sea applications for this. Okay, thank you. It was nice to meet everybody, and I'm pumped for the cohort.
Thanks so much. Next up, we have Thin Air Nav.
Hi, folks. Good to be here. My name is Blake, co-founder at Thin Air. We are developing a ground-based positioning system specifically for airborne systems in denied environments. We call this GPS in a kit or GPS in a box because it is essentially what you're looking at, just a set of beacons, the transceiver on the plane, that is designed to be portable and ready for rapid deployment, essentially anywhere on demand. We're currently at TRL5. We just conducted our first successful test flights last month, so we've now got a working prototype. A couple of points on the technical foundation. This is based on a technique called multilateration, which is something that's been around for quite a while. So we're not inventing new tech, so to speak. We've just repackaged what is typically seen in a permanent tower into a beacon, which is what makes this both portable and disposable. Obviously, towers are not practical in a contested environment, but multilateration is a very well proven, tested technique. So we've just made this now available as an alternative for contested, denied environments. The other key point is that we're designing this on entirely COTS components, commercial off the shelf. So it's designed to be extremely low cost, designed to be directly supportive of this replicator initiative as we move toward more autonomous, attritable systems that will need very low cost solutions if they want to be able to operate in a denied environment. That low cost also creates an economic advantage in the field because the cost to deploy this relative to the cost to effectively search and destroy is just a massive imbalance. In terms of our development, I'm still focused right now on BD, a couple of conversations with some key stakeholders in the government. We've been invited to participate at Pintax this year, which is kind of our big deal for the year. We were invited by C5ISR, which is an office within the Army Futures Command. Also preparing for some other demos at Silent Swarm and GIFX. And I'll leave it at that. Thank you.
Great, thank you so much. Next up, we have UltraView.
Hello, I'm Jack Medellin, the head of defense here at UltraView. So we are another drone company. Let's see if I can make this quick for everybody. So we are a US based, we built and designed the software in the US. We're based in Austin, Texas, and it's an autonomous drone that flies around the exterior of an aircraft currently to assess the damage on the outside, instead of people getting up on scissor lifts and scaffolding with pen and paper. Our main advantages are that we're LiDAR based navigation, so we don't need to use GPS, so we can operate inside of a building or in a contested environment. And then also we have reusable flight paths, and since it's autonomous, the operator doesn't necessarily need to know how to fly a drone itself. We're TRL6. Our main use cases are aircraft or spacecraft inspection and then digital twin generation. Our early traction is with our development partner out, it's called Ascent Aviation Services out in Tucson. And then we've got some pilot programs we're hoping to move forward with those on the commercial side. And then on the defense side, we have a couple of phase ones under our belt, and then MOUs with Warner Robins and Lackland. And then as far as the business model goes, we use a robotics as a service selling points. So that allows our customers to not need to be drone experts to fix anything or worry about their cloud costs. It's kind of an all-in-one subscription cost at $25K a month for 2 drones.
Great, thank you so much. Give me 1 minute. Let me see. Apologize here. Okay, next up we have Apiary Systems.
Yeah, thanks so much. Hi, my name is Tyler Fenstermaker. I am the CEO and co-founder of Apiary Systems. We are doing swarm software for UAVs, and the big problem we're seeing right now, I think before the replicator initiative was mentioned previously, and that's really what got us excited about putting this technology out there. And so what we do is we allow for multiple drones to work together on geospatial applications. And we are doing this right now with battlefield intelligence and with the idea of going into disaster response. And the traction that we currently have is a letter of intent from the Army Geospatial Center and a letter of support from some connections at the Joint Chiefs of Staff. We are students from the Ohio State University, and we recently won $50,000 in that university accelerator. And our technology is going to use a kind of engineering deployment, robotics as a service kind of business model similar to the last example that was given. Thanks so much.
Next up, we have Mithril Technologies.
Hi, that's me. I'm Scarlett. I'm the CEO and co-founder of Mithril Technologies, and we have a unique type of actuation for mesh reflectors for satellite applications. And when I say mesh, I do not mean mesh network. Get that question a lot. We mean a physical mesh that is used for deployable reflector antennas for satellites. Because of our unusual capability in controlling that surface and reshaping it on orbit, we actually enable a number of use cases across different space verticals, some in satellite communication, some in space domain awareness, and in atmospheric monitoring, because we enable unique flexibility and coverage of different areas. We enable scanning of large areas of space and then focusing in with a single instrument. And we enable a type of atmospheric monitoring that's been proposed multiple times by NASA and NOAA and has not actually been feasible until now. And in terms of commercial traction, we've got a lot of interest, especially in the weather section for insurance and shipping companies. And we actually have some interest in commercial satellite communications as well. On the government side, here's the rub. We've got a ton of interest being indicated out of AFRL and Space Systems Command for SATCOM and space domain awareness. They've even got a topic right now for space-based environmental monitoring, and NRO has supplied us a letter of support for application of this technology in signal intelligence, but we are really struggling a little bit with getting the government to actually put their money where their mouth is. We do have a fair bit of non-recurring engineering that's going to be required for the TRL raising. We are at TRL 3 right now. We're transitioning this tech out of my co-founder's lab in MIT Aeroastro. As for the recurring cost, we are working on expanding that out and doing a lot of development work to understand the different models that we're going to need to adopt to approach these different applications. Thanks very much.
Great. And I'm just going to stop sharing my screen really quick. For our last two companies, we don't have official slides, so they might be sharing some of their own materials. But next up, we have Bold RF. So if you want to give a brief background on your technology, capabilities, and business model.
Yes, I can have it. Sorry, let me see if I can share. Sorry about that. Can you see my screen?
No.
Nope. Let's see here. Share.
There you go.
There you go, right? Okay, thank you so much. Okay, hi, my name is Lila, and I'm the CTO for Bold RF and founder. And we design basically microchips for RF front ends, and our new chips, like most of them, like you can see different types of chips here that they enable what is called simultaneous transmit and receive. that's basically you're transmitting and receive at the same frequency and the same time. And that feature allows a lot of different applications in the defense world, like a simultaneous radar and sensing. Another application is if you were attacking someone and you want to see the effectiveness of that attack, you have to do some monitoring at the same frequency, at the same spot in time, frequency, and space. And also, it can be used simultaneously for communication systems. So basically, all of those chips, they are integrated in other parts like power amplifiers and mixers to make a new type of circuit that allows you to converge a lot of applications into just one radio and not using a lot of different radios on the field. So here, this is a spin-out technology from CU Boulder, where I got my PhD in phase arrays and microwave design. The TRL that we evaluated at this time is TRL3, because we have all of those chips fabricated and measured, and we are integrating them into just one, like a form factor. And in terms of business model, we are aiming to fabricate and commercialize those RF front ends. And visualizing that, we applied for an SBIR, a pitch for NSF SBIR, which we were accepted to present the first proposal, but we also submitted a joint proposal with CU Boulder, Lockheed Martin, Sandia Labs, and Corvo for the Swap Hub. A Swap Hub is one of the hubs that the CHIPS Act uses to transfer funding and design semiconductor chips in this new government type of funding. So in this context, we are going to fabricate those RF front ends, and Lockheed Martin will integrate them into their phase arrays. We are going to partnership with Sandia Labs for a heterogeneous integration that we are going to join other type of chips. And yes, this is where we are right now. Oh, yeah. And I'm happy I didn't put my website here, but yeah, I'm going to drop it on the Slack channel.
Okay, great. Thank you so much. And last but not least, we have Eclectic Systems.
Stop.
Can everybody hear me?
Yes, we can hear you.
Okay, great. Can I share my screen real quick?
Yes, of course. Should be the share button.
Okay, just one second. Shoot. Okay, sorry. It's giving me a little bit of issue here. Just one second. Why? Okay. Oh, sorry. Here we go. Okay. Screen. All right. And okay. And slideshow from beginning. Okay. Hi, I'm Yahya Mirza, the founder of Eclectic Systems, and we're building a very dense visual simulation appliance. So what it is, it's basically building an end-to-end hardware platform that we can use specifically for doing the kinds of simulations we would need in hypersonics vehicles and hypersonic systems design. So we've been working on this for quite some time. Originally, our plan was to do it specifically for the entertainment industry first and then go to aerospace. But then when the entertainment industry took a bit of a dive, we switched the order. So we worked with Intel from 2015 to about 2020, and we built end-to-end prototypes. So we're about at a TRL 6. We built our own CFD simulation engine and our own parallel rendering engine, and both of those will become embedded in our appliance. We have prototypes on CPUs, GPUs, FPGAs, software prototypes of our application. Our end goal is to be about 10x faster on the kind of relevant workloads we're doing, and we want to be about 1/6 the rack density and enable a set of new capabilities. So what this will give us, it'll give us a dense system that will be very useful for SCIFs. So we're using a kind of cooling technology called dual phase immersion cooling. So we're building specialized accelerators and servers that we dunk into this dielectric fluid, and this gives us about 1/6 the rack density that we have in current air-cooled systems at very little requirement for water. We don't burn water. We can actually just use the facility water and circulate that out. So there's no refrigeration or water cooling as normal would have. So this would be perfect use case for a SCIF. Back to use cases, we're doing this specifically for doing hypersonic CFD as you would use in vehicle synthesis. So I have a background in hypersonics. I worked in space access and hypersonics, scramjets and wave riders back in the late 80s and 90s before I transitioned into the software and computing industry. So we're also directly engaged with several feature film studios for applying this for an area called virtual production. Turns out that the workloads are pretty close. I mean, obviously the simulation models are different, but the kinds of technologies, the requirement for very rapid simulations are all very, very similar. We're already engaged with Space Force, DIU, AFRL, DoD, HPs, the High Performance Computing Modernization Program, and DOE. We're getting access to some DOE supercomputers, so we can do some benchmarking of the performance that we have with ours versus theirs. We're working closely with AMD. We're already engaged with Supermicro and Equus as our go-to-market partners, and we're engaged directly with the vice president of Sony Innovation Studios. Our business model is we work with an OEM partner, a device partner, and a cooling partner, and we build an integrated solution that we sell. And then, so the idea is that we'll have, for our first prototype, which is all COTS-based, which we should be able to bring to market this year. The idea is that we'll have devices that are in a specific combination, but then our goal for early next year is to build our own specialized servers and accelerator models. So our accelerators, and I'll leave it with this point, when you do computational fluid dynamics for hypersonics, you end up getting very low utilization on modern computing systems because they're largely designed for AI. Our workloads, while AI is important to us, it's not core to our workload. So that means we do a lot of simulation of physics. And when you're doing dynamic simulations, your utilization on your hardware gets to be less than 10%. Sometimes 10 to 30%, but it's very low. So if you spend, a $10 million supercomputer, you're going to get 1/10 the utilization of the flop. So what we're doing is we're building a board that has a networking and FPGA integrated directly with the GPU. So what we're building is a kind of a turbocharger for the GPU to make it more efficient. And we think this has significant use case in the cloud. And so our goal is to build our platform as a new kind of edge cloud for the space companies. So that's what we're up to.
Great, thank you so much. And then I will share my screen again, if you wouldn't mind sharing your screen.
And oops, let me stop the share.
Great, thanks.
Stop share. There you go.
Awesome.
Thank you.
Give me 1 minute, folks. Okay. So next
Oh,
up,
one last thing, sorry. We also built a space flight simulator that's functional already. So I just wanted to leave it at that. Thank you.
yeah, thank you so much. So that rounds out our 20 cohort teams. Next up, we have one of the unique aspects of the program is that companies are going to get one-on-one engagement with mentors. And so we have two types of mentors. The first are our government mentors, many of which are on the call today. We'll go over their brief backgrounds during our breakout sessions this afternoon. But each company will have the opportunity to engage with a mentor within the government, within the government a couple times over the course of the program. So we've outlined 3 different opportunities for that engagement, and we have gone through the matchmaking process to identify your mentor. So you'll be introduced to your mentor later this week. So we're really excited to have some of those folks join our call. The second type of mentor that we're going to have is within the NSIN Enterprise. We have a number of companies that have gone through a similar program called NSIN Propel, as well as companies that have been through the Vector program. So you'll have companies will have the opportunity to meet with their assigned mentee within the NSIN alumni organization a few times as well over the course of the program, and I think we have 2 weeks assigned for those folks, and they'll be able to be in the breakout rooms as well, and you'll be able to engage with them. So without further ado, we will start the breakout sessions. I'm going to give a little brief background on how we'll run them, and then we're going to run 3 breakout sessions, each 20 minutes. So you'll know when the time, when you have 60 seconds left, time remaining with that for that session, and then we'll move our mentors over to their next room. So the way that we're going to run them, companies will be each assigned a different room, and the cohort teams will stay in that room for the entirety of the breakout sessions. So for room 1, the first discussion topic will be with industry and colliders. So the cohort will gain understanding and exposure of the different resources that help bolster their commercialization strategies. The industry and collider folks, the government mentors, are going to provide more insight into what has worked and what hasn't worked through their experiences in working with early stage startups. And then in room 2, we're going to have programming and contracting be the focus. And so cohort's going to gain insights on different types of contracts and acquisition methods. And then the folks that are representing that sector are going to understand different common bottlenecks for early stage founders who want to pilot within the DoD. And then the last room will be for end users. So the cohort is going to discover and ideate on new underdeveloped requirements, and the end users are going to discover the realm of possible for use of the cohort's technology. So as you can see, we've broken out our cohort teams. We've broken out our government mentors based off of their expertise and background. So if you see yourself I would not focus on the room specifically, because you guys are going to be rotating to different rooms where the companies will reside. But you will be categorized as either industry collider, programming, contracting, or end user. And then for the cohort teams, when we start our breakout rooms, we're going to have 3 rooms open. So just make sure you annotate what room you've been assigned to. And then you can go to that room at the start of the breakout session. Does anyone have any questions about how we're going to run the breakout rooms? And Laura is going to be the champion here with getting everything organized and set up. But any questions from the group at large? The breakout rooms are going to be moderated by myself, by Julia, my colleague, and Caroline from the NSIN team. So we'll be in those rooms leading the discussions. Any questions before we get started? Seeing none. Okay, so our first breakout session, like I said, will be 20 minutes. We'll have until 4:30 for that breakout room. And it's really just a chance for the cohort to engage with some of the mentors that will be they'll be working with closely. For the companies the NSIN alumni companies that have joined us today, you can work your way through the different rooms and engage with both the government folks as well as some of the cohort teams. So we'll allow you the flexibility to go from whatever room you'd like to go attend. So we'll give you that flexibility. So when the breakout rooms open, you can go into the room that you'd like.
So rooms are all open. You are welcome to join the room 1, 2, or 3.
Yep. So Caroline will be in room 1, Julia will be in room 2, and I will be in room 3. And we'll get started.